Hi, we're going to do some special things about velocity time graphs. Two things that you need to know here. One of them is higher tier and one of them is both. So here we're looking at a velocity time graph which has got this special T shape. The speed or velocity up the side and the time along this horizontal line here. But sometimes they do this, they don't put the numbers in, so it might be useful sometimes for you to just jot the numbers in. Now in this one, with this T-shaped one, it means that this line is 0 meters per second, and then below it is negative and above it is positive. That's because velocity, remember, is speed in a given direction. So velocity can be positive and it can be negative. If you're going backwards, it's negative. So that'll give you an idea of what we're going to say here for this one. And then next, what else you can do in higher tier is work out the total distance covered on a velocity time graph. So let's look at one. So here we have a donkey, lovely. And this is what the donkey does to go and find some food. I haven't put any numbers in, but what I've put here is 0 meters per second for that line to remind us that that bit there is 0, so the donkey's not moving. It's positive at the top and it's negative at the bottom. So negative velocity means you're going backwards. Here we've got our normal velocity time graph. We can say that the donkey is accelerating, it's staying at a constant speed, and then it's decelerating. If you're not sure about that, go and have a look at the velocity time graph clip. So decelerating is quite straightforward. Now don't keep going down, because whenever you get to 0, you must stop. So at that point there, like the donkey, you must stop. The donkey has stopped at that point where it gets to 0. So it's slowed down here and stopped. Don't forget to stop. Now down this bit here, the numbers down here will get bigger. They're all minuses, but it'll be like minus, -1, -2, -3, etc. So write them in if you need to. So as the numbers are becoming increasingly negative, they're getting bigger. It means it's speeding up. It's speeding up in reverse. The numbers, it's going 1 meter per second, 2 meter per second, 3 meter per second. So this donkey is accelerating, oh thanks, in reverse. No need. Right, accelerating in reverse. It gets to this point, it doesn't stop, although some people really get confused here and think about the journey of a car or how your bike would look if it was following this route. But here, it's not stopped. What's happening is, look, the numbers are going back down again. They're still in reverse. So what's happening is it's slowing down in reverse. Slowing in reverse, or decelerating, but I can't spell that. Stop, remember, you've got to align. You must stop there. The donkey has stopped. Stop. Okay, so you stop at that point there where it hits 0. So there again. So stationary donkey, and then it accelerates and decelerates again until it finds its carrot. So when this happens on a velocity time graph, you've got negatives, it's going in reverse. Now the other special thing about velocity time graphs is you can work out the distance travelled. When you've got a graph like this, what you have to do is chop it into triangles and rectangles. They won't make it too complicated on the exam paper because you'll be there all day, but have a look what I'm doing. So I'm chopping these lines up. Oh, lovely piece of work. Oh, look. Wait. Imagine that was straight. Right, there, like that. So I've chopped it up into as many rectangles or squares and triangles as I can, and then I need to work out the area of each of these shapes. So here I can use the scale. 20 times 3. So that's 60. 20 times 3 is 60. But it's a triangle, so you half it. So that's 30 meters. This one is 20 along and 3 up. So it's 3 times 20. It's not a triangle, so it's 60. And so on and so forth. So this will be 30 times 3. That's 90, etc. And then you add all the numbers up, and that is the distance.